Alright, we're going to do some two-step equation examples with some fractions, roots, powers of 2. As always, we're still going to move that furthest thing. I know I'm not writing as many words as before, but hopefully we all know what this means now. And then we're going to do the opposite. And when we say move, we're still saying the opposite. And then we're going to do the opposite of the closer to the variable. And we're still going to be doing it on both sides, but I'm, cutting down on the explanation in hopes that I could just do more. Like here, we've got a root and a multiplying by 2. I can't do a power of 2 yet because it's A, the root is closer. The 2 is further away, so I'm going to want to get rid of the 2. But B, if I did a power of 2 to both sides, I would still have to apply it to this 2 also. That makes it more complicated. So here, when you see the root in the x, 2 outside, you want to divide first. Still have root x equals 9. Sorry, I started doing that step before explaining it. And then the opposite of root, power of 2 to both sides. Cancel, cancel. Not 18, it's 81. Wah, 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 wah. Okay, I'm going to leave the fraction ones to the end. Here we've got divided by 4 and a power of 2. Same thing, I can't just root that x squared without rooting the divided by 4. So I want to get rid of that divided by 4 first. Multiply by 4 to both sides. Still have x squared. Now it's much easier for me to deal with, and then I can just take a square root to get rid of that power of 2 and get two answers, positive and negative 8. Okay, I'm going to jump down here to look at this problem, just so that, I know I should have lined it up better, but whatever, it's fine. Here I've got a power of 2 and a negative 10, and just like this problem up here, I can't get rid of that power without getting rid of the number first. So here, I'm going to do that. I'm going to get rid of my multiplication step first. And get x to the power of 2. Flip that because I got opposite or same signs, always positive. Opposite of a power of 2, root out, positive negative 2. But that it's not a universal case. Like if you look at here, my root is on the outside, so I would have to get rid of that root first. By doing a power of 2 to both sides, and then I'll still have 2x equals 36 here, and then my division step would be last here. I guess you could see a similar case of this if you had parentheses negative 10x to the power of 2 equals something. Let's just make it 4 so I could make the problem work. If it was like this, then yeah, you would have to do the root also first. So it's not always just the multiplying, dividing, then the root. It depends still. Whatever's furthest away is always what we're going to get rid of first. And then afterwards, yeah, we'd get some funky fractions, but that's okay. Fractions are fine. Alright, now that I added an extra example to the examples I was doing, let's go to the fraction ones. So in general, the fraction ones, you can have it two different ways. So I'm even going to draw this problem twice. Some kids like to say, okay, I just have a fraction, I know the reciprocal of a fraction will multiply out to get rid of it, so I'm going to multiply by the reciprocal to both sides. And my 5's cancel out, my 2's cancel out, I still have x. Here, I want to put that 10 over 1 to make it a little bit easier for me to multiply. Remember when you multiply fractions, you go across the top, across the bottom. But I can cancel the 2 into the 10 first and make it 5's. 5 times 5 gives me 25. And if you multiplied across, you got 50 over 2. You would have been able to divide at the end there also. The other way students look at it, or I've seen students do it, is they will get rid of one at a time. So let's say I'm going to get rid of this divided by 5 first, and multiply out, and get 2x equals 50, and then divide out. So two different ways to do the same problem. It's up to you to choose how you want to do it. I think this is probably a more efficient way, but I'd rather have you get it right than be efficient. Down here, same thing. I'm going to multiply by a reciprocal. Okay, so look at this. This x here versus this x on top. This is the same thing. If you have 2x over 5, that's the same thing as 2 over 5 times x. Because when you're multiplying with the top. So just know that these are the same. And it's just another math thing. They're not really telling you everything, but they want you to know that. Alright, so we're multiplying by negative 9 divided by 4 here. So I'm going to multiply by negative 4 over 9. Sorry, my 4's are getting a little weird. Both sides, negative 4 over 9. And I got a negative negative cancel here, that's very nice. And then here, this is pretty gross. I can't cancel in my 9 to my 16 or my 4. I got opposite signs when multiplying, so I get negative. And then I just got 64 on top for multiplying 16 times 4. 9 on the bottom, and I'm going to call that a day. Maybe I could have simplified it, but I don't want to. Okay, so overall, if you want to see more fraction examples, let me know. But you're going to either multiply by the reciprocal, or you're going to get rid of the dividing part first, then the multiply part after. It's up to you. Yep.